Welcome to everyone. This is Bharat from TBK Career Point channel. Now we are going to discussing about regularization concept. Regularization, it is useful to prevent the overfitting problem in the deep learning concept, and at the same time to improve the accuracy. So actually, basically, this regularization techniques are one of the technique is dropout technique. So dropout technique is regularization technique that involves randomly ignoring or dropping out some layer outputs during training used in deep learning neural networks to prevent overfitting. By randomly disabling neurons, the network cannot overly rely on the specific connections between them. ఎందుకు ఇట్లా జరుగుతుందంటే sometimes the neural network it is learning the um, complete data and it is memorizing some data. సో మెమరీ డేటా మొత్తం మెమరైజ్ అవ్వడం వల్ల సో యాక్యురసీ అనేది హై యాక్యురసీ వచ్చేస్తుంది అనమాట, ఓవర్ ఫిట్టింగ్ వెళ్ళిపోతుంది. సో టు ఓవర్కమ్ దట్ ప్రాబ్లమ్ వీ కెన్ యూస్ ది టెక్నిక్ కాల్డ్ డ్రాప్ అవుట్. అంటే సమ్ న్యూరాన్స్ ఆర్ గోయింగ్ టు బి డిజేబుల్డ్. So then there is a possibility that balancing of the neurons, balancing of the accuracy will be uh, between the training and the testing cases or validation. So these two cases, the accuracy will be balanced. At the same time, one more technique it is called early stopping. So early stopping, so it is the main intention of these techniques are to reduce the loss and to improve the accuracy. So the validation loss, if it starts increase, stop, prevent. If you observe in this diagram, so training error and testing error. So the training error and testing error, sometimes at some particular stage low, so testing error is going to will be very high. సో ఒక పర్టికులర్ పాయింట్ దగ్గర హైకి వెళ్ళిపోతుంది. సో అక్కడ ఎప్పుడైతే హైకి వెళ్ళిపోయే పాసిబిలిటీ ఉంటుందో దేర్ వీ కెన్ స్టాప్ ది ట్రైనింగ్ అండ్ వీ కెన్ రిఫైన్ అగైన్. సో వీ కెన్ చేంజ్ సమ్ అదర్ పారామీటర్స్ ఆర్ వీ కెన్ స్టార్ట్ ది ట్రైనింగ్ బై చేంజింగ్ సమ్ వాల్యూస్. సో ఈ పాయింట్ ఏమంటే ఎర్లీ స్టాపింగ్. సో దిస్ ఈజ్ ఆల్సో యూస్ఫుల్ టు increase the accuracy and to reduce the loss between the training and testing errors. So as we can see here, we can observe here. So this is the, so one more technique is there, and L1 and L2. So these two techniques are useful at the same in the same direction to reduce the loss and to improve the accuracy. So these two techniques are useful using two cost functions. So one technique, L1 technique using this cost, L loss plus lambda by 2 into summation of absolute magnitude of weight, and L2 cost function it is using loss plus original loss plus lambda by 2 into summation of magnitude of weight square. So by adding these two penalty terms to the original loss, so we can expect the loss is going to be the reduced, and the possibility of the accuracy will be high. And the next technique is called data augmentation. So sometimes the data is not sufficient, then again the model is leading, or it is going towards the overfitting. So in that case we have to increase the sample size. So to increase the sample size, so the data augmentation will be useful. So in the Keras we have a function called image data generator. So by using this data generator, so we can improve, we can increase the number of samples in the category wise or class wise. So whenever the data set is increasing, then there is a chance of balancing the data set, and the machine will learn the data properly, and it gives the proper accuracy, and at the same time loss also is going to be reduced. So by having these all techniques, so we can, our intention is to improve the accuracy and to reduce the loss. So in the case of overfitting only, so will use these type of techniques to improve the, to maintain the proper accuracy of any type of model in the convolutional neural networks or the deep learning. Thank you all.